Hello and welcome to another stats warm-up. So again, these are questions that you could see on the open-ended portion of your final exam. So what do we have? An English teacher figures that 12% of all sentences they read from students will have some sort of grammatical error. If the teacher picks a random collection of sentences, what is the probability that the first sentence with a mistake is the seventh one she checks? So let's think about this. If 12% have an error, that means 88% are error free. All right. So this is basically saying the first six don't have a mistake, which happens 88% of the time. And we're saying we need that to happen 6 times in a row. And then the seventh one has a mistake, and that has a 12% chance of happening. All right. Now, if we put this in, 0.88 to the sixth power times 0.12, you'll get 0.0557. Now, you might be saying to yourself, Mr. Volna, isn't this similar to like the geometric distributions we did? And you're right. We could do this using GeoPDF. All right. We could go to our distribution menu and go to geometric PDF. And the reason this is a geometric situation is we're counting how many tries until our first mistake. All right, success is usually the language we learn, but it's weird to call a mistake a success. But we're counting the number of trials into our first success. So that's geometric PDF. We could say the probability of a mistake or a success is 0.12, and we're saying what are the odds of it happening on the seventh try? And you're going to see that this gives us the same exact answer. So whether you show this as your work or whether you show 0.12 comma 7 as your work, either way is fine by me, and either way is going to give you the same answer of 5.57%. All right, but this is a geometric situation because we don't know how many times we're counting how many trials until our first success. Right? Now let's compare that to B. B says the same teacher is at lunch one day and notes that she checked 32 sentences that morning and didn't find mistakes on any of them. Is this result surprising? Is our teacher losing her edge? Explain. All right, so again, this is easy enough to do without using the special features on the calculator. She checked 32 sentences and there were no mistakes. There's an 88% chance of having no mistakes, and it happened 32 times in a row. 0.88 times 32 is 0.0167. Now, we could also think of this as a binomial setting, all right? Binomial settings have a fixed number of trials and you're counting your successes. So what about when we have 32 trials and there are 0 successes? What are the odds of that? So we could go to distribution, binomial PDF. There were 32 trials. The chances of finding a mistake were 12%. We want to know what are the odds of ending up with 0 mistakes. All right, so if we were going to write this, we would write B PDF 32, comma 0.12, comma 0. And you're going to see that I get that same result. All right, so 0.0167, or put another way, both of those are telling us that it has about a 1.67% chance of happening. All right, now C is one where we're definitely going to want to use the calculator. All right, trying to do this manually would be very cumbersome. If a teacher looks at 20 sentences, what is the probability she will find errors in 7 or more of them. All right, so fixed number of trials, that tells us we're using binomial, and we want to do from 7 and up. Now, the tool that we're going to be using is binomial CDF, but this does from a number down, and the question is asking for a number up. So what we're going to do is we're going to flip it around and say 1 minus B CDF. And even though it says 7 or more, when we set up our B CDF, we're going to use 6. And the reason that we're using 6 is by subtracting away 6 and lower, 7 and up is left. All right, so even though the problem says 7, when we're subtracting, we have to subtract away 6 and lower, so that 7 and higher is left. And then we can type that in. So 1 minus, go to our distribution menu, binomial CDF. This time there were 20 trials, still 12% chance of finding a mistake. And we're subtracting away 6, 5, 4, 3, 2, 1, and 0, which is going to leave 7 and up. All right. And this gives us 0.006689. Or you could also write that as 0.6689%. All right. But you are very likely to see an open-ended question on the final that deals with binomial and geometric distributions and knowing how to calculate those or use the correct features on your calculator to help you calculate those. All right, number 2, a simple random sample of 1,100 males aged 18 to 29 in the U.S. were asked whether they used the internet for games. 775 said they did. We want to use this information to construct a 95% confidence interval to estimate the proportion of all U.S. males aged 18 to 29 who use the internet for games. All right, state the parameter our confidence interval will estimate. So this is what are we creating an interval for? And that would be the true proportion of all U.S. males 18 to 29 who use the internet for games. All right, but we've got a sample about that. We're trying to estimate the true value across the entire population. Now, give the 95% confidence interval. All right, you do not need to calculate these by hand. All right, you are welcome to. All right, it would be the point estimate plus or minus z star. And then because this is a proportion, you'd be using PQ over N. But you do not need to. Right? You are welcome to use the calculator. So that would be the stat test menu. This is dealing with proportions. All right, so we know we're using one of the proportion intervals, and there's only one situation going on here. There's only one group that we have information on. So this is going to be a 1 prop z interval. All right, so I can just say 1 prop z interval. All right, the x is the 775. The n is the 1,100. And this one is asking for a confidence level of 95%. All right, so I can just fill that information in. 775, 1,100, 95%. All right, and that's going to give me an interval from 0.67758 to 0.73151, Or put another way, like 67.758% to 73.151%. All right. This P right here was your sample result. So the sample result was about 70.5%. So that's the middle of our interval. And then we have to go a little bit above that. We have to go a little bit below that. And how much we're going above and below depends on the confidence level, which informs the Z star, and it involves the standard error of your sampling distribution, which we find using this formula. Okay. So there's our interval. And then there's some more questions on the back. Interpret the confidence interval constructed in part B in the context of the problem. All right, so this is just kind of that standard sentence that we've been writing, but basically, I am 95% confident the true proportion of U.S. males, what was the age range? 18 to 29, who use the internet for games, is between, let's round that. We'll make it like 68% and 73%. So we'll drop the decimals there and just say like 68% and 73%. Okay. So that's sort of putting it in the context of the problem. D, this poll was conducted through email. Explain how the sampling procedure could lead to a biased estimate in this case. Also speculate about the direction of the bias. Right? So if you're conducting it via email, the sample is tilted towards internet users. Not that there's a lot of 18 to 29-year-olds that aren't using the internet, but if you're conducting it through email, you're more likely dealing with heavier internet users. So the sample is tilted towards internet users, which probably biases your results in an upward direction. All right, you're estimating that the proportion is higher than it actually is. All right, so maybe not the greatest way to conduct your survey. You might have to kind of rethink your polling process and gather new data. All right, number 3. People have been complaining about winter lately. They feel like the snow and cold is getting worse. The historical average for snowfall in the area is 75 inches. People want to know if the snowfall is significantly worse or if it's all in their head. Below is a table with snowfall data for the last 20 years. Does this sample indicate that the masses were right and snowfall has increased as of late? Test an appropriate hypothesis and state your conclusion. All right, so choose your alpha level and state your hypotheses. Again, our alpha is always that there's no difference. So in this case, we're dealing with quantitative data, so we would say that the mean is still equal to 75. Our alternative, we're getting from this sentence that says significantly worse snow. So we're going to say that U is greater than 75. If it had just said different, we would have used not equal to. If it had said, significantly better, we probably would have used less than. Though worse and better probably depends on your opinion of snow in this case. And then alpha, we don't have a compelling reason to use anything different. The problem doesn't tell us to use anything different. So we're just going to stick with 5%. All right. So calculate your test statistic and p-value. Again, you do not have to do that by hand. You are welcome to use the calculator to do that. So we're going to go to stat tests, and then you have to be able to identify which test you're actually using. All right, so we only have one set of data here, so we can pretty much rule out any of the two sample tests. We're not dealing with proportion, so that rules out the one proportion z-test, and it basically leaves us with z and t. Now, hopefully you remember that I've told you we never use z. All right, z is if you know the population standard deviation, and we don't know that. All right, so we're going to be using t-test. Now, you can either calculate the stats yourself, or you can put this data into L1. All right, and that's actually what I've already done. All of these numbers have been already entered into L1. So 86, 75, 83, so on and so forth. So I can just go to stats test, t-test. All right, I'm going to specify what I'm doing. So this is a t-test. I'm using the data option. And then it is important that you still specify your null. So my null in this case is 75. If you don't put that number in correctly, you're going to get the wrong results. My list is L1. My frequency is 1. So let me just put that down. List is L1. Frequency is just 1. And then again, this is another one where it's important to make sure you're picking the right thing. We're testing to see if the value has increased, if it's greater than the mean. So we need to choose that one right there. All right. Once we've done that, we can hit calculate. It'll give us our test statistic. That's the t right there, so 3.5962. It will give us our p-value. Now, be careful on these. I've been taking a lot of points off on this lately. The p-value is not 9.624, all right? P-values are percentages. They have to be constrained from 0 to 1. Notice there's a little e to the -4 there. This is scientific notation. Your p-value is 0.000, the paper there, 0.0009625 if we round it. Or you're welcome to write that as 0.09625%. Either way is fine. All right. I would just leave it because what if you accidentally goof it up when switching it over to a percent? And I will give you full credit for that. So I would just leave it. The only other things they're showing here is the sample mean. So the sample mean was 78.6. So it was higher than that null of 75 we were testing. The standard deviation was 4.47 for this sample right here. And then our sample size was 20. All right, so here's our p-value. We have to state our conclusion. And basically what we're saying is based on what we got, based on these results, right, it was very unlikely to get results like this if this was true. So our conclusion would be that because our p-value is less than our alpha of 0.05, we reject the null and accept the alternative. All right. So in context of the problem, it's basically us acknowledging that, yeah, winter's been a little worse lately. Okay? So again, all questions that you could see. Hypothesis testing will definitely show up on the open-ended part. Confidence intervals will definitely show up on the open-ended part. And then geometric and binomial distributions is likely to be a question that shows up as well. All right, so make sure you know how to do these. And if you have any questions, just reach out and let me know. All right, have a great day.